Hi kids, now we'll be going with this paper discussion. You can look into the first question. The first question says there are two infinite current carrying wires like this, and okay, there is a rectangular frame with capacitor. So they are asking what is the maximum induced EMF, charge and current. So why there will be induced EMF in the first place? Because the currents are varying. Currents are varying with time. So when the currents are varying with time, flux here will be varying with time. So when there is variable magnetic field, then it will be creating induced electric field which will be draining the current. So let us see. So current is in this direction. So because of this one, flux here will be in which direction? This is the current carrying wire. So L bar cross R bar. So flux here will be outward direction. What about due to this one? It will be inward. So flux due to this one and this one are opposing. So let me try to find the flux because of this wire. So I will be taking some element at a distance x whose thickness is dx. So I will be finding the magnetic field here mu naught I1 by 2 pi x into this area. This area is 1 into dx. So that is the flux through this region. So I will be integrating all those and I will be ending up with this. That is from 2 to 4. I need to integrate from 2 to 4. I will be getting this result. Now similarly I will be finding the flux because of this wire. For that I will be taking element here at a distance y. Magnetic field is this much and this area is 2 into dy. So I will be integrating from where to where? 1 to 2. So finally I will be getting this one. But these two flux are opposing in nature. So net flux will be 1 minus 2. Right. So this minus this. Yeah. That's the net flux. Now if I want to find the induced EMF, then I will need to see at what rate the flux is changing. So I am differentiating it. This is the rate at which flux is changing or magnitude of EMF induced. Magnitude of EMF induced. Now di1 by dt, I1 is given in the question, so I can differentiate it and substitute it here. I2 is given in the question, I can differentiate it and substitute it here. So that's some induced EMF, but they are asking what is the maximum value of induced EMF. So what is the maximum value of this thing? This is like A cos theta plus B sin theta, right? A cos theta plus B sin theta, maximum value will be root of A square plus B square. So you can do that maximum value. Now okay, fine. From there you will be getting option B as correct, option A as wrong. Now maximum charge. Now maximum charge will be given by Q is CV, but they are asking maximum. This maximum is equals to C times of this maximum. This maximum we have already found, so you can just substitute it, so that you will be getting the charge maximum. Then they are asking some instantaneous current at some point of time. So if I want to find instantaneous current, I need to find instantaneous charge. Instantaneous charge is C into V. So this is instantaneous potential difference, right? So this is the instantaneous charge. If I want to find instantaneous current, then it will be C into dE by dt. E we know. Now differentiate this and put it here. So you will be getting current. Differentiate this and put it here. You will be getting the current. Now T equals to pi by omega. Just substitute it and you will be getting the answer, right? Okay, in the next question there is a YDSC setup. They are asking what is the minimum value of D for which there will be a bright fringe here, right? So when nothing is there, what will happen? Yeah, I mean, when the sources are like at equal distances, then it would have been bright fringe here. I mean, path difference will be 0, right? Now, okay, let us see the figure. Path difference must be n times of lambda here. Now, one path length is this, one path length is this. Now you can see this path length is more. So how much more it has to be? It has to be like integral multiples of d. But if they are asking minimum value, then path difference will be d. Or else let me find what is this length, and what is this length, and let me subtract it. So what is this length? This length is root of d square plus d square. And what is this length? Root of 3d whole square plus d square. That is this length. And what is this length? This length is d plus 3d, 4d. So that path difference must be integral multiples of lambda. But if d has to be minimum, then here it has to be minimum. So minimum and lambda. So that is 1 lambda. Thereafter I am taking like d common. And thereafter I think they have given the information. They didn't give the distance d is very large when compared to small d. So this is very large, this is very small. I can go with binomial approximation. I went with binomial approximation and I ended up here. Yeah, from here I will be getting d value. So from there you will be getting option B as correct. So nothing, its path difference has to be integral multiples of lambda, that is 1 lambda for d minimum. Now in this case, where the central bright fringe will be formed, for this value of small d, where the central bright fringe will be formed. What does it mean by central bright fringe is formed? Path difference has to be 0. So I will be finding this path length and I will be finding this path length. The path difference has to be 0, or this path length and this path length must be same. So what is this length? This length is this much. What is this length? Yeah, you have to be careful here. Now this length is how much? y, this total is y, this is d, so this will be y minus d. This is 3d, this is y minus d. So hypotenuse will be root of 3d whole square plus y minus d whole square. That is this length. Now this length is d and this length is root of 3d whole square plus y square. So I need to find the difference, and that difference where it will be 0 I need to check. Now again in the same way I am taking capital D common, then I am going with binomial approximation, binomial approximation, binomial approximation, binomial approximation, and thereafter I was expanding it and I got this much, but D value we have just calculated, right? So we will need to substitute that D value and get the answer. A charged particle Q is moving simple harmonically on x-axis with its mean position at origin. Amplitude of the particle is A and angular frequency is omega. The particle is performing SHM. Okay. The magnitude of electric field at, okay, we'll go for the figure. So something is performing SHM. They are asking what is the magnitude of magnetic field here. Now you know if a charge is moving, then the magnetic field you will be calculating using this formula. Now V bar cross R bar. If you are talking about this point, V bar will be along this line and R bar also will be along this line. When two vectors are along the same line, angle will be either 0 or 180, so cross product is going to be 0. So magnetic field here is always 0. It is not going to vary periodically. The maximum magnitude of magnetic field at 0, A. So that is here. Here they are asking what is the maximum magnetic field. If the magnetic field has to be maximum, V has to be maximum and R has to be minimum. Now the good thing going to happen here is when it is coming from here to here, that distance is decreasing and velocity is increasing. So here it is going to be maximum. Velocity is increasing, distance is decreasing. So here it is going to be maximum. So yeah, mu naught by 4 pi into Q into V bar cross R bar by R cube. Now these two are perpendicular. So V bar cross R bar will be V into R, where R is this distance which is A, by R cube, the distance is A cube. Now it is performing SHM. It is performing SHM. So maximum velocity will be A into omega. Amplitude is A, right? So from there you will be getting option B as correct. Magnetic field at A comma A at the moment it passes through A by 2 comma 0. So when it passes through A by 2 comma 0, I need to find what is the speed, what is this distance. Then I need to use formula mu naught by 4 pi into Q into V bar cross R bar by R cube. So I need to find velocity. For that I am going with energy conservation. When it is performing SHM at the maximum, at the extreme potential, it will be entire energy will be potential energy. That will be converting as potential energy here plus kinetic energy here. From there I will be getting V value. Yeah, I mean that omega value, you know, M omega relation with K and M, right? So I just substituted omega. So I will be getting the velocity here as root 3 by 2 A omega. Now I know now this distance is A, I know. This distance is A by 2, I know. So I can find this distance as root 5 by 2A. Now I can use V bar cross R bar. Mu naught by 4 pi into Q into V bar cross R bar, that is V into A into sine of angle between them. V into this distance into sine of angle between them. Sine of angle between them is A by root 5 by 2A. V bar cross R bar by R cube, this cube. Yeah, that's all. Velocity you know, root 3 by 2 A omega, just substitute it, you will be getting the answer. The magnitudes of magnetic field at 0 comma A and 0 comma minus A. So when it is at some random position, this is 0 comma A, this is 0 comma minus A. Now it looks symmetrical, like this distance is same as this distance, this angle are same. So the only thing is here magnetic field will be this way, here the magnetic field will be this way. But magnitude wise they will be same. The next question, there is a liquid which is filled up to 3 by 4th of the total height. So total height is h, it is filled to only 3 by 4th and you are rotating it such that liquid is just about to fall out. So then the entire liquid is inside only. It is going to form a paraboloid. The whole situation is shown in the. Okay, now they are asking what is the height. See, it is not flowing out. So the meaning is I can do volume conservation. Now before that, I want to show you something. Yeah, I mean this is not exactly like volume of paraboloid, but I have done something here, mass enclosed. So I can show you volume of this paraboloid is nothing but if you draw a cylinder which encloses this. If you draw a cylinder, volume of the paraboloid will be exactly half of the volume of that cylinder. Volume of paraboloid will be exactly half of volume of this cylinder. So if someone asks you what is the volume of this paraboloid, you have to draw a cylinder. You have to draw a cylinder and you need to say this volume is half of the volume of the cylinder. Now what is the volume of this cylinder? This cylinder volume is pi r square into h naught. So volume of the paraboloid will be half of pi r square h naught. So if the volume of the paraboloid is half of the volume of the cylinder, then what is this volume? This volume will be remaining half, right? So for this cylinder, I mean, if I say volume of the cylinder is V, volume of the paraboloid will be V by 2, so volume of the remaining part will be V by 2. Now what is the total volume of water in this figure? This volume plus this volume. This volume is how much? Pi r square into h minus h naught. Now this volume is same as volume of paraboloid, which will be pi r square into h naught. Now that's the total volume of the water finally, which must be the same as total volume of the water initially. It is filled to only 3/4 of the height. So this is the initial volume, this is the final volume. No water is flowing out, so I can do volume conservation. From there, when I solve it, I will be getting what is the value of this h naught. Now once I get the value of h naught, then I can find some other stuff here. Yeah, I have gone with like bigger lengths. You can take for smaller lengths so that you will get option C and D by yourself. You can take dx and dy and you can get the option C and D by yourself. I am going for option B. So for that I am taking one imaginary cylinder here, imaginary water cylinder here. Now this is performing circular motion. When something is performing circular motion, net force towards the center must be equals to m omega square r. Now here it is atmospheric pressure, so the force will be P naught into A. Here the pressure is P, so P into A. Net force is P into A minus P naught into A. That equals to mass of this. Mass of this is density into area into the length. Length is r. So m omega square, center of mass. Center of mass is performing circular motion, which is at a distance r by 2. M omega square, center of mass, circular motion. Right. So that is for this guy. Now for this guy is in equilibrium in vertical direction. So I can net force equals to 0 along vertical direction. Here there is P naught into A. Here there is P into A, and there is weight also. Weight is rho into A into this height we calculated already. So h by 2. Or you can say like when you go down, pressure is going to increase, whatever it is, right? So I have taken horizontal imaginary cylinder of water, I have taken vertical imaginary cylinder of water. I have written F equals to ma in both the cases. In the second case it is 0, in the first case it is not 0. Now from here I will be solving that unknown. P is not known, so I am just adding them. When I add them, P will get cancelled, P naught will get cancelled, I will be ending up with omega, right? In the next question, the radius of spherical capacitor are equal to A and B. The space between them is filled with dielectric constant. The inner electrode is given a charge Q naught. Choose the correct options. Yeah, so if there is no dielectric, that is going to look like this. If I are giving a charge Q naught here, yeah, it will come onto the surface. I can prove it by taking Gaussian surface here. Yeah, if you didn't watch revision class, I have explained it little better there. I'll be taking Gaussian surface here. Electric field is 0 everywhere, so charge enclosed must be 0. So no charge will be here. There will be Q naught. So similarly, I can take one more Gaussian surface here. I can show you flux is 0. So total charge enclosed must be 0. If this is Q naught, this will be minus Q naught, and this total charge is 0 already. So if this is minus Q naught, this will be plus Q naught. So this is how it looks initially. Now if I put dielectric, what is going to happen is the charge is going to leak from here to here, but when it is leaking also, this two will always be equal and opposite. Outside charge will always be constant, right? So right now there is field here as well as outside, but in the final situation this charge will be totally flowing here, and this Q and minus Q is going to become 0. So the field here which was present earlier is going to disappear, right? It is going to disappear, but outside field is going to remain same. So there is some field which is disappearing. So the meaning is there is some energy, the electrostatic energy, which is disappearing, which will be going as heat. Now if I want to find what is that electrostatic energy disappearing, I'll be seeing like what is the energy present in this region before. So for that, what I will be doing, I will be taking some element and I will be seeing what is the energy present there. Half epsilon naught E square is the energy per unit volume into, if I take some element here, what is the volume of that element? If I take at an radius r, so 4 pi r square dr will be the volume, right? This is energy stored per unit volume into volume. Now be careful here. Now the electric field is how much? Electric field, if there was no dielectric, the electric field would have been kq by r square. Now because there is dielectric, you will be getting electric field will be 1 by k times of earlier value, right? So this is the energy stored in that element. Now if I integrate from A to B, I will be getting what is the energy stored. So I am integrating from A to B and I am getting what is the energy stored in this region initially. Now where is this energy going? This energy is going as heat. So from there we will be getting option D. Now how much time it will take? It is like discharge, right? Capacitor and resistor is there, so it is like RC discharge. So you know it is going to look like Q naught into e power minus t by RC. This charge is going to look like Q naught into e power minus t by RC, right? After a long time it is going to become 0, not instantaneously. After when t tends to infinity, it is going to become 0. Now that time constant R into C, I have done in the revision class, I have shown you like R into C is going to be a constant. R into C is going to be a constant for any situation. Like parallel plate capacitor is the easy way of getting it back if you don't remember. So that's the reason I didn't do what is RC there. So RC I know it is rho k epsilon naught. So option 1 will be correct. Option C will be correct because after a long time it is going to become 0, but not after immediately. Next question, a small object moves counterclockwise along the circular path whose center is at origin. As it moves, the acceleration vector continuously points towards S. Okay. Then what will happen to the object as it moves from A to C and C to A? If you see here, when it is going from A to C via B, then if you take any particular, like here or here, you can see here it is 90 degrees, here the angle between velocity and acceleration is 90 degrees, here the angle between velocity and acceleration is 90 degrees. But if you take any region here, any point here, then you can see like, okay, if you talk about this point, velocity is this direction, acceleration is this direction. Now acute angle, so the meaning is acceleration's component along velocity supporting it, so it will be increasing its speed. It will be increasing its speed. Acceleration's component will be along the velocity, so it will be increasing the speed. So from A to B it will be increasing the speed, but when you go from A to C it will be increasing the speed. From C to A you can see the angle is going to be obtuse. When the angle is obtuse, when you resolve the acceleration vector along the velocity, it is going to be opposing, so it will be reducing its speed, right? So increasing, reducing. So in the next question they are saying if a plane wave is moving positive x-axis, it is going to look like this. So but if it is in 3 dimension, I mean like in some random direction, then it will be represented using this way, so that's fine. So we need to get it into this form, minus k bar dot r bar or minus k into n cap dot r bar. We will see how to do that for this thing. So this is the equation given. I can write the same thing as minus k bar dot r bar. R bar is xi cap plus yj cap plus zk cap. I can write the same thing like this. So this is going to be k bar and this is going to be r bar, right? So minus k bar dot r bar form we have written. Now the same thing I can write it as k into its unit vector. Its unit vector is this by its magnitude, right? So or else I will be dividing and multiplying with its magnitude. This magnitude is root of 2 square plus 2 square plus 1, which is root 9, which is 3. So I am dividing with 3 and multiplying with 3. So this is the magnitude of k and this is the direction of k, right? So magnitude of k I know, so 2 pi by lambda is k, so lambda is 2 pi by 3, right? So I will be getting that. Now the wave vector, wave vector is making this much angles, right? The unit vector is 2 I cap by 3 minus 2 j cap by 3 minus k cap by 3. Now how much angle it is making with x axis? So I need to take the dot product with I cap. Like this is the vector. Now this vector, what is the angle between this vector and I cap? How, if I want to find, I can take the dot product of their unit vectors, right? So then I will be getting cos theta, right? Magnitude is 1, right? 1 into cos theta. Dot product is a bar dot p bar is a into b into cos theta, so that 1 is to 1 into cos theta, that is 2 by 3. Now similarly between this vector and minus k cap, like I can take the dot product of this one with minus k cap, it will turn out to be 1 by 3, right? So they are not, so this with x axis it is making cos inverse 2 by 3 and it is not making equal angles with positive x axis and negative z axis, so both are wrong. And they are talking about particles 0, 0, 0 and 1, 1, 2 are in the same wavefront. So now we know the line equation, we know the ray equation. So if you know the direction cosines, then the plane perpendicular to that line will be given by direction cosine into x minus x1, direction cosine into y minus y1, direction cosine into z minus z1 equals to 0. So they have given 2 points, so it must be satisfying this equation if it is lying in that plane. It is not satisfying the equation, so the meaning is both are not lying in the same plane, in that wavefront. Now in the next question they have given 2 waves. You can see like both are looking similar, the only difference is negative sign. So we have already seen this is moving along some random direction, but its component along x-axis it is moving along positive x-axis, that you have seen, right? So it is making an acute angle with x-axis, so its component along x-axis is in the positive direction. So if the velocity is v, what is the angle? Angle is 2 by 3. So if the velocity is in some direction, now what is its component? Let me say this velocity is u. So what will be its component along x-axis? Its component along x-axis will be u cos theta. So that is u into 2 by 3. So I have taken the velocity as v. So what will be its component along x-axis? 2v by 3. So this wave is traveling along positive x-axis if I take the component. This wave is traveling along negative x-axis if I take the component. Both are equal speeds. You can see, right? K value is same, omega value is same, right? Now there is a guy who is moving along positive x-axis. This is the situation. Some sound is coming with speed 2v by 3, some sound is coming with speed 2v by 3, and some sound is coming with 2v by 3, some sound is coming with 2v by 3, and I am moving in this direction with pi. So what will be the frequency heard by me? There will be different frequencies, so they are asking what is the beat frequency. Now if I am collecting the balls, like I'll be visualizing like they are the balls. Now if balls are coming with speed 2v by 3, I'll be collecting the first ball. After how much time I'll be collecting the second ball? That's like relative speed is 2v by 3 plus pi. So with respect to me, the ball will be moving with 2v by 3 plus pi into time, let me say t1. So this is the distance traveled by the ball, like, right? So for which I'll be collecting it. I am collecting the first ball, and I want to collect the second ball. So that ball speed with respect to me will be 2v by 3 plus pi into time taken is t1. Okay, that is the distance between the ball and me. That is 2v by 3 into t, or like wavelength component along x-axis. So that's fine. Anyway, you can see like final equation, right? Now what about this guy? This guy will be emitting balls, but relative to me, that the guy's speed will be 2v by 3 minus pi relative speed into time interval, that equals to the distance between the balls, or this is t1. So 1 by t1 is frequency at which I will be collecting these balls, 1 by t2 is the frequency at which I will be collecting these two balls. So I am doing this. Now this must make sense, because speed of the sound, that is speed of the ball, plus speed of the observer when they are moving towards each other, right? When observer is moving towards the source. So plus pi. So when observer is moving away from the source, you will be getting minus pi. This must be making sense because Doppler's effect, right? So from there you will be getting what is the relative, what is the apparent frequency heard by the guy. This is the apparent frequency of this sound. This is the apparent frequency heard by this guy for this sound. So finally I was getting the values, and f0 is v by lambda. Lambda is 2 pi by 3. When I am substituting, I am getting 9 by 2, but they have given some other thing. I don't see anything wrong in what I have done. So if there is anything, maybe I will be letting you know in next discussion, right? In the next case, a long rectangular slab with variable refractive index. Refractive index is varying like this. I think this similar question has come already in one of your exam. So there is a regular algorithm to solve this question. It is like we will be writing Snell's law and we will be writing slope equation. So it is refractive index is varying with x coordinate, so we will be taking some imaginary, we will be taking a slice of slab here, and when the slabs are parallel to each other, we know mu sin theta is constant. So I will be applying Snell's law between this point and this point. So this is the normal, this is the slab, so this is the normal, this is the ray, so angle of incidence is theta. If this angle is theta, when I draw that tangent to that curve, then this angle is going to be theta, right? Alternate angles. Yes. So I will be applying Snell's law between this point and this points. Here it is 1 sin 90. Here it is mu sin theta. So I am applying Snell's law between this point and this point. Thereafter, slope of this curve will give me dy by dx, right? So dy by dx will give me tan of this angle, tan theta. These are the two equations you need to write and you need to solve them. So tan theta I need to find. So I will be finding sin theta from here. I will be drawing the triangle. I will be finding tan theta from here, and I will be substituting it. Mu value is given in the question. I will be substituting it, and I will be ending up here. There are only two variables, y and x, so I will be taking x terms to one side and y terms to other side, and I will be integrating, and I am getting some curve equation like this. So I am getting some curve equation like this. So when y is d, what is the value of x we need to find. When y is d, what is the value of x. Once I know what is the value of x, I can substitute it back to get the refractive index, right? 1 plus e power x by d. Okay, in the next question, there are 4 short electric dipoles, 3 of dipole moment p and 1 of 2p. They are asking what is the electric field strength at origin. So the first thing what I will be doing is I will be resolving the dipoles along this and perpendicular to this. So all the dipoles. P by root 2, 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 2P by root 2, 2P by root 2, which is root P and root P. Now, due to this dipole, the field here will be, they have given the values in such a way, this is root 2R, so this will be 2R, this is going to be R. So, due to this dipole, field here will be 2 Kp by root 2 by R cube. Due to this one, 2 Kp by root 2 by R cube. So, this, due to this dipole and due to this dipole, it will be getting cancelled. Due to this dipole, it will be in this direction. Due to this dipole, it will be in this direction. Those two also will be getting cancelled. Due to this one and due to this one, it will be getting cancelled. Now, due to this one, it will be 2K into this dipole moment by distance cube. Now, due to this one, dipole moment will be in this direction, field will be in this direction, which will be K root 2P by R cube. So, these two yellow things are because of these guys. Now, due to this one, it will be 2K P by root 2 by R cube. Due to this guy, it will be in this direction, which will be K P by root 2 by R cube. Now, we need to find what is the resultant. Now, this is 2 root 2 minus root 2, so which is root 2 Kp by R cube. This is root 2 plus 1 by root 2, so which will be 3 by root 2 Kp by R cube. That Kp by R cube I am calling it as E for easy understanding. So, what will be its component along this direction? 45. So, if I call it as E, root 2E. Root 2E's component is E and E. Now, this component will be 1 by root 2 times of this, that is 3 by 2E and 3 by 2E. Now, the resultant of these two along x axis is 1 by 2E. Resultant of these two along this axis is 5 by 2E. So, the resultant is going to be 1 by 2E. E is Kp by R cube along the negative x axis, 5 by 2E along positive y axis. This is what they are asking, right? So, they are asking what is the value of x plus y. An inductor, resistor and battery are connected in series. The ratio of energy stored in inductor and energy dissipated in resistor up to. So, it is a charging circuit. When it is a charging circuit, you know the current is going to look like this, where time constant is L by R, maximum current is E by R, these things you know. They are asking what is the energy stored till one time period, right? 1 when t equals to tau. So, energy stored in the inductor is half Li square. They are asking what is that we need to find what is the current at t equals to tau. When t equals to tau, it will become e power minus 1. So, current is going to be I naught into 1 minus e power minus 1. So, that square. That is fine, you do not have to bother much. That is the energy stored in the inductor now. Now, what about heat? If I want to find heat, then I need to go with I square R is the power, I square R dt is the heat at any small instant. If I want to find throughout from 0 to tau, I need to integrate it. So, I square I know from here, I will be just substituting it, I will be expanding it and I will be integrating it. Substitute the limits properly, e power 0 is not 0 and you will be ending up with something. Now, they are asking what is the ratio of those two. Just take the ratio of those two and compare with the given equation, you will be getting the answer. In the next question, fine, I will show the figure and I will be explaining. There is vacuum here, but this spring is compressed initially, so it will be pushing this piston with K into X. That compression is 0.1 given, so this spring force will be K into 0.1, K into 0.1. This is in equilibrium, so K into 0.1 must be equals to this pressure times of this area. So, both pressures must be same, both volumes are same, both temperatures are same, both number of moles are going to be same, fine. So, area I am going to take it as N, A for easy understanding. So, what is the volume? Volume is A into 1. So, what I can say, this piston is in equilibrium, so this pressure into this area equals to this force, that I can write. Now, in the later moment, I am hitting this, I am hitting this, I am assuming this is becoming, earlier it was 1, now it is becoming 1 plus L1, this is becoming 1 plus L2. So, this is going by L1 and this is going by L2. So, spring will be compressing extra by L1 plus L2. So, spring force is going to become K into 0.1 plus L1 plus L2. Now, this spring force will be equals to this pressure into this area. This spring force will be equals to this pressure into this area. From there, I can conclude both pressures are same. Now, this volume is how much? Earlier volume was A into 1. Now, the volume will be A into 1 plus L1, that is A plus AL1. This volume will become A plus AL2. Right. So, I can write. For this piston, it is in equilibrium, so this pressure into this area equals to this force. So, those two things I can write. Now, I need to use something like, this is gas, right? So, PV equals to nRT, like between these two gases, between those two gases. So, anyway, these two gases are in the similar phase initially. So, I can directly write PV by T equals to nR. So, this PV by T will be same as this PV by T initially. So, this PV by T finally must be same as this PV by T. So, I am equating all the PV by T's. PV by T here equals to PV by T here, which is equals to PV by T here. this volume is A into 1. I didn't write 1. Yeah. Now we need to get L1 and L2, but we don't know P1 and P0. So we need to eliminate P1 and P0. For that I am going to take help of these two guys. So P1 by P0. P1 by P0 will be this by this. So P1 equals to that much times of P0. That much times of P0. P1 equals to this much times of P0. P1 equals to this much times of P0. Thereafter I am cancelling P0 and A. Yeah. Now from here I need to solve it. The way how I approached it is, I have taken this term and I have taken it this side and I got something like this. This is in the numerator, right? So it went into the denominator and stuff. I am calling this as K. So by equating this thing to this thing, I am getting it as L1 equals to 4K minus 1. If I equate this to this, I will be getting it as 5K minus 1. L2 is 5K minus 1. Now L1 I know, L2 I know, so I am going to substitute here. L1 is 4K minus 1, L2 is 5K minus 1. So I am just substituting it. 4K minus 1 plus 5K minus 1 is 9K minus 2. I am just substituting it here so that I will be getting a single variable K. So I am getting a quadratic. I am going to solve that K value. Now this value is given in the question. 481 root 481 is 22 given in the question. So I am just substituting it and I am getting the K value. But I don't need K value. I need L1 plus L2. L1 plus L2 is how much? L1 plus L2 is 9K minus 2. Yeah. L1 plus L2 plus 0.1. Initially it was 0.1 compression, thereafter extra compression L1 and extra compression L2. This is what I need to find, that is 9K minus 1.9 I need to find. 9K I know, so minus 1.9 is going to be the answer. A uniform heavy plank of length L resting A and B are of identical length. Okay, identical length. Now they are of identical length and you are putting some rod, so what will happen, they will get compressed, but it is in equilibrium, it is in horizontal position, so the meaning is this compression is same as this compression. That is what you need to understand. So I will be checking why it is in equilibrium. Net torque must be 0, so this distance into this force equals to this distance into this force. Yeah, both L's are small L's, you can take small L, capital L. Now from there I will be getting N1 by 2 equals to N2 by 4. Now how to get the force relation with Young's modulus for this guy? I know Young's modulus is stress by strain, so force will be Young's modulus into area by length into change in length. Now area and length are same for both the guys. Now change in length is also same, so force is proportional to Young's modulus I can say. So force is proportional to Young's modulus I can say, right? So y1 by 2 equals to y2 by 4. So from there I will be getting the relation between Young's modulus. From here you will be getting the relation between Young's modulus. Now they are going to heat it. So if you take a rod of length L and if you heat it, its natural length is going to become L into 1 plus alpha delta T. But what you are doing, you are compressing it and putting it back. So what is the change in length? This was the natural length. So change in length will be L alpha delta T. Change in length is this much. So once you know change in length, natural length is L plus alpha delta T, but I am going to put almost same as L, yeah, because it doesn't make much difference, right? So from here they are saying stress in such a way that thermal stress is 3 times, right? So stress is Young's modulus into delta L by L. Delta L by L is alpha delta T, right? So this stress is 3 times of this stress, they said. So that's fine. So from there we will be getting alpha by alpha 2 is, alpha 1 by alpha 2 is this much, but y2 by y1 you have calculated from here, just substitute it back. In the next question, there is a chain which is released. Determine the velocity when half of the length has fallen. So drop in potential energy equals to change in kinetic energy, or else I can visualize this yellow thing. Look at the yellow color thing. Initially chain was like this, finally half of the chain is here, half of the chain is here. Now if you look at this first half, this half is going to look as it is not changing. So this half I can visualize it went here. So I will be seeing like what is the drop in potential energy when this goes from here to here. So its center of mass is here, which is, yeah, this is L by 2, so this is L by 4, this is L by 4, so this will be L by 8. So initially this center of mass is at L by 8, now it went to L by 4. So L by 8 plus L by 4 is the drop in height, from here it went here, right? So L by 8 plus L by 4 plus L by 4, L by 8 plus L by 4 plus L by 4. So that is the drop in potential energy of this guy. that is the length, so into mass into g. Now this is only m by 2, right? This total mass is m, this mass is m by 2. M by 2 is dropping by a height L by 8 plus L by 4 plus L by 4. M by 2 is dropping by a height this much. So this is a drop in potential energy which will be going as kinetic energy of the total thing, right? From there we will be getting the answer, right? There is a right angled prism. A horizontal ray strikes the face PQ, undergoes total internal reflection twice as shown. The refractive index of the prism is mu and angle is theta. We need to find what is the refractive index. Okay, so let us draw the figure. This is coming like this, angle of incidence is 0, so the ray will be passing as it is. Now we will be drawing a normal. This angle is 15 degrees, so this angle is going to be 15 degrees because this is same parallel thing, right? This is 15, this is 15 and this is 90, so this is going to be 75. So these angles we know. This is the normal, so this is going to be 75. If this is 75, then this will be 75 and stuff. Angle of incidence equal to angle of reflection. So if this is 75, this will be 75. If this is 75, this will be 15. Okay, it will be going here and it will be hitting. Now when I draw the normal here, I need to find the angles here. I have drawn this normal, right? I have extended this normal. Now this angle is 75. Okay, that much only we know. This angle is 15. Okay, we'll see the other way. Yeah, this angle is 75, right? So if this angle is 75, this angle is going to be 75 because same parallel lines, alternate angle, right? Yes, this is 75, this is 75, so this is going to be 30. If this is 30, this is the normal, so this is going to be 60. If this is 60, angle of reflection will be 60. So this one will be 30. Now this will be going here and it will be hitting the normal. Now this is a triangle, so total angle must be 180. This is 50 plus 30, 45. So this one must be 135. This is 90. So this is going to be 45. So angle of incidence is 45 here. If angle of incidence is 45, what will be the angle of refraction? I can use Snell's law. No, they said something like it is also coming out horizontally. It is also coming out horizontally, right? So this normal and this normal, they will be parallel. Though I have drawn it slightly different way, but these two normals will be parallel, right? It's the same line. So normal will be parallel. So this horizontal, if it is making 75 degrees, then this one also will be making 75 degrees. So this 75 degrees I can understand from the given information. So if I know this is 75 degrees, this is 45 degrees, I can apply Snell's law and I can get the refractive index, right? So it's more about geometry. You need to find the angles and just use Snell's law in the end. So in the next question, they were saying at t equals to 0, number of nuclei are n0. At t equals to t1, it is n1. At t equals to t2, it is n2. And the activity here is a0. And the activity here is a1. And activity here is a2. Activity is lambda times of n1. This much you know. They are asking what is n1 minus n2. n1 minus n2 is a1 by lambda minus a2 by lambda. 1 by lambda is nothing but tau. So it's a straightforward question. Okay, in the next question. In the next question, they are talking about something like a screw gauge whose least count is 0.005 mm. So the meaning is, what is the least value you can measure? What is the least value you can measure? Like one circular scale division is the least value you can measure. So one circular scale division is 0.005 mm, they said. So when the screw gauge is placed without any gap like this, it is not showing 0, it is showing 4, they said. It is showing 4th division of circular scale, they said. So when you put an object of length 0, it is showing some length. How much is that length? 4 times of circular scale division. So when you put an object of 0 length, how much it is showing? 4 times of one circular scale division, which is showing 0.020 mm. So when you put an object of 0 length, it is showing this much. Fine. Now they said when a wire is placed to measure its diameter, the reading of the main scale advances by 6 divisions. 6 divisions. Circular scale reading becomes 3 times to the corresponding reading when an object was placed. So initially it was showing 4 circular scale readings. Now it is showing 3 times of that. That is 12 circular scale readings. Okay, and there are 200 divisions on circular scale. So 200 divisions on circular scale. So there are 200 divisions on here. It is 100 only, but in the given question there are 200. So when you are rotating one full circle, how many circular scale divisions have been rotated? 200. So for 200 circular scale division, for one circular scale division, you know how much it will move, right? How much it will show. For one circular scale division, it will show this much. So for 200 circular scale divisions, how much it will show? It will show 1 mm. For 200 circular scale divisions, it will show 200 into 0.005. So the meaning is, when you rotate the circular scale division one complete full rotation, it will be moving by 1 mm. So I can say this main scale reading, yeah, depending on. So once you rotate this one by one complete rotation, this is advancing by 1 millimeter. So main scale reading is 1 millimeter. When you rotate completely, main scale reading is, yeah, it will advance by 1 millimeter. So one main scale reading is 1 millimeter. Now main scale advances by 6 divisions. When you put an object, it is advancing by 6 divisions. One main scale reading is this much. So 6 main scale readings will be 6 times of that, right? Plus what they said, it is showing 12 times of least count or 3 times of initial value, right? Extra. So this is because of main scale reading, this is because of circular scale reading. But what is the problem? The problem is, earlier we can see when the length is 0, it is showing extra. So if we want to find the actual length, we need to subtract this much. We will be subtracting it, then we will be getting what is the actual length. So what is the length we measure? That is the diameter, right? Thank you.